Hi everyone. For this assignment we are going to take a look at the 4 different ways that we have learned to solve quadratic equations and when you should choose the different methods depending on the quadratic equation given. So let's take a look at the zero product property. When can you use the zero product property to solve a quadratic equation? When the quadratic is factorable. You can't choose this method unless the quadratic is factorable. The quadratic factors. All right, so you would put your quadratic equation in standard form as you typically would do for all quadratics when you solve, and then determine the method to use. So once it's in standard form, you can check to see if it factors, and if it does, I would choose the zero product property. This is always my go-to method. If I can't factor it, then I look for other methods to solve. The second one that I look for is the square root property. When can you use the square root property to solve a quadratic? The only time you can use it is if you have a perfect square. If you can set it up in the form such that you have a perfect square that equals a number. All right, so you can use it when you have something that looks like this. X squared equals any number, 7. If you could set it up so that you have a perfect square that equals a number, you can use the square root property. You can also use it on something that looks like this. Okay, so you have to have a perfect square that equals a number. So if I don't have the zero product property, if I can't use that and I can't use the square root property, then it doesn't really matter which one you choose next. Sometimes completing the square is easier and sometimes the quadratic formula is easier. They both take about the same amount of time if you know what you're doing. So let's talk about completing the square. When do I choose to complete the square? I choose to complete the square when, let's say, I have ax squared plus bx plus c equals 0. If we divide by a, sometimes a is 1, so that makes this really easy. If we divide each term by a, if b over a is a nice even number, all right, I choose completing the square typically to solve my quadratic. Why does that work nicely? Because if it's an even number, then when we divide by 2, we get a nice number to square and add to both sides. We don't get fractions. So I choose completing the square when b over a is a nice even number. And I choose the quadratic formula for all others. The quadratic formula can always be used to solve a quadratic regardless of the form of that quadratic, right? Once you put it in standard form, regardless of whether it's missing the bx term or the c term, you can always use the quadratic formula to solve. Okay, so this is for any others. So let's take a look at solving some of these equations here. So the very first one, I don't even know if I can factor this. So this is an equation, so I'm going to divide every term here by 6 to see what I have. And I have x squared minus 1x minus 2 equals 0. Well, there are definitely factors of -2 that add to -1, so I'm going to use the zero product property. Okay, this one factors, so my reasoning would be that the quadratic factors. And so my solutions are going to be 2 and -1. So on your homework associated with this assignment, you are to state why you chose that method. The reason I chose this method is because the quadratic factors. All right, how about this one? Well, I can set it up as a perfect square that equals a number, right? Here's my perfect square, here's my number. I don't even have to simplify, like divide both sides by 16 if I don't want to. So I have a perfect square that equals a number, so I can use the square root property. So I am going to divide both sides by 16 because it makes it a little bit easier, and I'm going to put my perfect square on the left-hand side. So now when I use the square root property, I can't forget my plus or minus, so I end up with t equals plus or minus 4 final answer. So again, I chose the square root property because I have a perfect square that equals a number. All right, so how do I make a determination for the bottom two? Well, I like to put things in standard form and make sure that my leading coefficient, when I divide by my leading coefficient, I don't get fractions and I don't get odd numbers. And if I get that even number for B when I divide by A, then I use my completing the square. So I want you to visualize these two. If I divide all my terms by 3, is this number even? It is, so I'm going to choose the square root property. Let's look at 4. If I divide all my numbers by 8, the number in front of just the m to the first power is going to be a fraction. I would choose not to use completing the square for this one. I would choose the quadratic formula. So for this one, I would choose completing the square. This one, I would choose the quadratic formula because it's doesn't lend itself easily to completing the square. So let's solve number 3. We get x squared plus 4x equals negative 14 thirds. And when I complete the square, right, I'm going to take that 4, I'm going to divide it by 2 and square it. So I get 2 squared, so I am going to add 4 to both sides. So when I factor, I get x plus 2 squared equals, that's 12, that's going to be a negative 2 thirds. When I take the square root, I get x plus 2. I cannot forget the plus or minus. Plus or minus the square root of negative 2 over radical 3. Okay, so that has to be rationalized, and I have to take the imaginary unit out. So what do I get here? I get plus or minus I radical 6 over 3. And then to solve, I'm just going to subtract 2 from both sides. And I get 2 answers here. All right, so for this one, for number 4, so again, for number 3, I use completing the square because when I divided by A, I got a nice even number, and that lends nicely to completing the square. But for this one, I need to put it in standard form because I decided not to use completing the square. I'm going to use the quadratic formula. So I get 8m squared minus 2m minus 7 equals 0. So I also notice that negative 56, there's no factors in negative 56 that add to negative 2, so I can't even factor. So this is a good one for the quadratic formula. So I get m equals 2 plus or minus the square root of 4 minus 4 times 8 times a negative 7. All over 2 times a is 16. So I get 2 plus or minus 4. This is going to be positive. So this is 56 times 4 is 224, I believe, over 16. So now I get 2 plus or minus the square root of 228 over 16. Well, this is definitely divisible by 4. Let's see. That goes in 57 times. I know that this is divisible by 3, and that goes in 19 times. All right, so when I reduce that, I get 2 plus or minus 2 radical 57 over 16. And all of these numbers, 2, 2, and 16, have a common factor of 2. So I'll get 1 plus or minus the square root of 57 over 8 as my 2 answers. Alrighty, and that's how I want you to work the assignment for our asynchronous day. I want you to determine which method to use. You need to pick 2 equations for each method. Okay, tell me why you picked those equations to solve using that method, and then I want you to solve it. So there's 8 quadratics to solve. Have a good day, students.